The instantaneous heaters again, additional operating costs. If the water's 0 grains per gallon hard, soft, no increase. 5 grains, $400 increase, $358 increase, up to about $1,500 increase if your water is very, very hard, increase in cost. This is a chart showing that same type of thing in energy drop-off. Soft water, over 10 years, no drop-off, but the harder the water you get, the more the energy loss that occurs with the heating of the water. This is a gas storage tank water heater, again, up to 30 grains, increased cost of $700 versus 0 for soft water. But it starts right away at 5 grains per gallon, increasing the cost. Here's the amount of scale collected. Now in the gas storage tank water heaters, they found 500 or so grams per year of scale accumulating. You go to the electric water heaters, and that goes up about double, about 600 to 1,000 grams per year of accumulated scale. So a lot more scale, a lot more energy goes into getting that scale out of the water with your electric water heaters, and it's going to put stress on the element. The cost of electric energy, though, did not show any difference over the life of the softener with the electric storage tank water heaters. Carbon footprint again with the gas storage tank and the instantaneous water heaters, we saw a carbon footprint change. Now appliances, we looked at laundry washers and dishwashers. We set 3 of them up, and they were automatically programmed to put in laundry detergent, and they got standard laundry, and they washed 8 loads a day for I don't know how many weeks it was to simulate an accelerated use. And really, there's some data in the report, but the most dramatic things I think shows this is the dishwasher on softened water, I believe, versus dishwasher after the was used with hard water. Laundry washer, soft water, laundry washer with dishwasher. Here's the washer spray nozzles with hard water, and you can see some of these are plugged. There's softened water and hard water, many of them are plugged. So the results in general, all products with softened water, water heaters operated in softened water maintain the original factory efficiencies. Gas storage tank heaters with hard water can lead to as much as 24% loss in operating efficiency on 26 grain water. The tankless heaters operating on hard water failed after 19 days, and the efficiency would drop from 80% to 72%, about 8% in 2 years. Shower heads on hard water lost 75% of flow in less than 18 months in this study. So even the newest and the most efficient water heaters, the tankless, become more efficient with soft water. Softened water prevents this drop in energy efficiency that can happen quick, eliminates the need for regular scale removal, which translates into big costs, up to 50% more cost. And hard water has a tangible impact on shower heads as well. Is 10% big? Yes. The most energy efficient water heater in the market, the tankless heater, is 10% more efficient. And it also, softened water reduces the operating costs. Water heaters are the second biggest energy user in a residence. Consumers are switching to more energy efficient appliances to cut energy costs. And most manufacturers of water-based appliances recommend that consumers use soft water. In fact, I think the tankless will not honor their warranties if there's evidence of hard water scale in a failed tankless unit. The study showed that water heaters are more efficient, operating costs are saved with softened water, and it supports what we've had in those studies from previous years. As I said, the UK national building regulations require water treatment to prevent lime scale and hard water, all hard water going to heating applications. And they also have a criteria for branding or labeling water softening treatment devices as energy savings products. This was financed by our Water Quality Research Foundation. We thank them for that. And this, again, is where you can get a copy of the full report. I think that's it.
We have a couple minutes for questions for Joe. We have a question here. We got a mic over here, table.
Hi, I'm Sheriff Batra. I had a question about the water softeners. You mentioned two things: water softener softens water and it produces salt. And that salt has to go to water treatment plants where the energy that would have gone into water softening is now taken at the treatment plants, and the treatment plants have to use that energy to remove that chloride level. I don't know if the study looked at that carbon footprint at the treatment plant level, and what happens is that the chloride in the water reclamation plants, when it's reused for water irrigation and other purposes, has a much higher chloride level due to water softeners. And there's actually a bill that was in California this past year that would eliminate water softeners in jurisdictions because of the salt that is produced that ends up at the treatment plants. I don't know if, and the wastewater. And I don't know if that study addressed how energy intensive water softeners are on both on the treatment plants and where it is used in the home.
If a municipal wastewater plant is going to go to salt reduction, then they probably have to go to some kind of desalinization process like reverse osmosis membranes, and that would take energy to take the salts out. There's more salts that come into a wastewater plant than just what comes from water softeners, of course. So you couldn't tag all of that energy to a water softener. This study, we really didn't get into that because in most parts of the country, the need to take salts out of wastewater is not a need. It's not, the salts aren't that high. Even in Orange County, for example, where people do have water softeners, probably 5% of the salt in the wastewater is from those water softeners. And 95% is from other things. But anyway, it's true that if you're going to have to remove the salts from the wastewater, that is an energy consumption. Now, one option that we would have from an industry is to not discharge those salts into the sewer system, to write an algorithm so that when the salts come out of the regeneration cycle, the water softener regeneration cycle has about 50 gallons of water, and the amount of salt that's drawn out of your brine tank is only about 2 gallons of water. That's where all the salt that goes into the water softener is from 2 gallons of brine, and then it's diluted to 50 gallons of regeneration water. But we try to get that salt to go through the resin bed as concentrated as we can, so we can probably catch it in less than 50 gallons coming out, store it, and haul it away. But that too would be an energy consumption of having these trucks go out there and pick up this brine and haul it away and discharge it to an alternate disposal, but it would not be a wastewater treatment for the brine. But in any case, that was not part of this study. We didn't talk about taking the salts out of wastewater because it's not a universal problem that has to be done where that has to be done. This law you talked about is really the law used to be in California that consumers had a right to softened water, and a municipality, a local jurisdiction, could not take that right away from them. This new law was changed so that a local municipality, when it goes through a due process, can now restrict water softeners, whereas before it couldn't. So the law does not ban water softeners. It just allows local municipalities an opening to go through a due process and an ordinance to put some kind of restriction on water softeners. Could be a ban, likely will not be that much of a restriction.